Okay, welcome to Java OCA Unit 3, Lecture 3. This one is on iterations and loops. In this lecture, we will talk about awkward formatted for loops. We will discuss do-while loops, and we will examine the break and the continue statements. So here we're looking at for loops. For loops are counted loop statements. The format consists of three parts. These three parts must be separated by semicolons. So those parts are the initialization statement, the terminating condition, and the update clause. And if we look over here in the example to the right, we have the initialization statement. We are initializing a variable I to 0. We have the terminating statement that as long as I is less than 5, the loop will run. Once it's 5 or greater, it will terminate. And the update clause, I is being incremented by 1 after each iteration. For loops generally follow this template that you see here. Again, it is initialize, semicolon, condition, semicolon, update clause. And then you have your code block. And we see this code gave us the output of each iteration, 1 through 5. But as always with the Java OCA course, we want to examine the oddly formatted for loops. We look at the poorly structured program code. So here, the minimum requirement for a for loop header is a for loop with parentheses and 2 semicolons. There's nothing in there and it will run. And if you notice here on the right, this code runs perfectly well and it will print the number 1. But notice I had to put the break statement in because this would have been an infinite loop otherwise. There was no starting number, there was no terminating condition, and there was no update clause. So if you were to run this without the break statement, you would get 1 printed repeatedly for infinity, and it would eventually overload your processor and crash your computer. So the parentheses must contain 2 semicolons, which separates the 3 parts, whether they are in the header or not. It is a legitimate for loop. The code compiles and executes. And again, we had to put a break statement in so it didn't go into an infinite loop. So if we continue with these oddly formatted for loops, you can see that we still have the 2 semicolons here. And because the semicolons are on the left and on the right of what we have here, that means that this must be the terminating condition. Based on what is next to the semicolons, whether they're to the left or to the right or in between, you can identify if you're looking at the initializing statement, the terminating condition, or the update clause. And here you can see we initialized our variable before the for loop, a equals 1. And then we had the terminating condition in the for loop header in between the 2 semicolons. If those semicolons are missing, it will not compile. You need them both there. And then we have the update clause in the body or the block of the for loop. And this for loop works and it prints out what you see here. So all 3 parts are necessary, but they don't have to be in the header. But those 2 semicolons are necessary. So here are 2 popular errors that you have to look for with for loops. The first error is if only 1 semicolon is being used, then you're going to have an error because we said you need both semicolons to create the partition of the 3 conditions in the header. Whether the conditions are defined in the header or not is unimportant, but those 2 semicolons must be there. So this one here does not compile. Error number 2, both semicolons are there, but in this one, there was never an update clause, not in the body of code, not in the header. So this one is going to cause an infinite loop. So these are 2 types of errors that you have to look out for on the OCA exam. So if the update clause is missing, or if the terminating condition is missing, that's going to put you into an infinite loop. And if you only have one of the semicolons and not both, you're going to have a compile error. And just like our if statements can be defined without braces, so too can our for loops be defined with no braces. And just like with the if statements, if you have no braces, the for loop's body of code is only the first line after the header. So here we see there's no braces, and the first line after the header is line 9. That is the only line that will be repeated through the for loop. And after the for loop exits, then this line over here, the system out print name, will run. And we see that here we used a random letter generator to generate a 5-letter word, and this is the 5-letter word that was here. Now, if we had used braces, if I put braces after the header, and then if I included the system out inside the for loop, then this output would have printed N, then it would have printed NU, then it would have printed NUR, then it would have printed NURQ, and then it would have printed NURQB. But because we didn't have the braces, it waited until all 5 letters were concatenated in the word and printed it once. So again, when you're tracing code and you're determining the output, if the braces were there, this would have been the output. If the braces aren't there, then this is the output. Next up are while loops. While loops repeatedly execute code until a condition is no longer true. While loops are often the source of unintended infinite loops in need of fixing. However, while loops provide a technique of coding that allows a process to repeat based on user interaction and feedback. So we see here that first thing the while loop does is check if the condition is true. If it is true, then it does the statement or the block of code. And in that statement, there should be an update to the condition to keep it true or to make it turn false. And eventually it'll turn false and it should leave the while loop. But if you don't have it set up to turn false, it stays in that while loop forever and you have an infinite loop. And infinite loops are sometimes necessary, but they should be user controlled for when they can exit. So here you see we have an example of an infinite loop that only ends when the user's feedback provides a necessary answer to exit. So it changes the condition from true to false. We see that the string response starts with the letter Y stored in it, so that when it gets to the while loop, it says, does response store the letter Y? And that's true, so yes, it'll enter the loop, and then it'll generate 2 random numbers for X and Y, and then it'll ask the user, what is the answer to X and Y? It'll get feedback, and after the user enters, it'll tell them whether they're correct or if they're wrong. But then after that, it says, would you like another problem to answer? And it says type Y for yes, and if the user types Y for yes, they stay in the loop, and it'll keep going until eventually the user types something different than Y, and in that case, it will exit the loop because this condition will no longer be true, and then it prints goodbye, letting them know they've left the loop, they've left the program. So the while loops provide this type of environment that allows the program to go on for as long as the user deems necessary. And just like our for loops and our if statements, while loops too can have no braces. And if they have no braces, as always, only the first line of code is part of the body of the while loop. And we see here that this code runs and executes perfectly well. And inside of the print statement, it is updating the value of X. So it's doing a lot in that one line. So it's taking X and it's updating it to half its value. Notice the first thing it prints out is 200, not the 400 that X was initialized to. And with each iteration, it reduces it by half, and eventually it gets to 25. And as long as it's greater than 25, it'll print. And once it comes in, the last time it comes in, it's 50, it's greater than 25, it prints, but it gets turned to 25 as it prints, and then it exits the loop. So here we have a one line of code with no braces that satisfies everything. Another type of loop that OCA will test you on is called a do-while loop. Do-while loops are loops that you expect to execute at least once. No matter what the condition is, it'll run the statements at least once, it'll update the clause, and then it'll check the condition after it's done one iteration of the loop, and if it's still true, then it will go through subsequent iterations. And you see here we have the template for the do-while loop, and here is just a simple example using the do-while loop. x starts at 5, it'll print out 5 with a space that follows. It will decrease the value of x, and as long as x is greater than 0, it'll keep going. So this should print out 5, 4, 3, 2, 1, and then exit the loop. And finally, the last topic that we want to discuss in this lecture are break and continue statements. We've seen the break statement used with switch statements before. Now we're going to see them used with other loops, such as the for, while, and do while loops. And here on the right-hand side, for the break statement, when you're in a loop, once you have something, usually you have an if or some sort of an if conditional, and you say, if this is true, let's break out of the loop. And then it takes us to the end of the braces and it gets out of the loop, and no future iterations are run. However, the continue statement allows you to just skip the rest of the steps in the current iteration that you're in, and it brings you back to increment to the next iteration and says, let's run it again. We just skipped the rest of the code that followed. Let's start the next iteration. So the continue lets the loop go through the rest of its life cycle. So here is an example using the continue statement. In this example shown here, we have the variable I, which is set equal to a value. And if the value happens to be a multiple of 3, then the continue statement will say skip the printout. We don't want to print out any multiples of 3. Let's go to the next iteration and then print that out and continue. And if we find another multiple of 3, we'll skip printing that out, and so on and so forth. And you'll see that we have 1, 2, there's no 3, 4, 5, there's no 6, 7, 8, there's no 9, 10, 11. So it kept skipping the multiples of 3. So it says if I modulus 3 is equal to 0, continue means end this iteration. Let's go back. Let's increment to the next number. Maybe it's 4. I modulus 3 is not, or 4 modulus 3 is not equal to 0, so it would print 4 and go on and so forth. So the continue statement is a useful one for when you just want to skip an iteration with certain conditions, but keep running through the loop regardless. And here is an example using the break statement inside of a while loop. And you'll see here in this example that if the variable x is equal to 7, it will break out of this loop entirely. It won't run any future iterations. It's not like the continue statement. It'll say, all right, we're done with this loop, let's get out of here. And you'll see that after we ran this, it printed 10, 9, 8, because x started at 10. It went through and it says, if it's ever equal to 7, break, get out of this loop. It printed x followed by a space, it decreased x, and that's what we got. Once it hit 7, it cut out, no more iterations were run. So that is the end of this lecture. Watch it again, take notes, do your skills check, and send me questions if you got them.